In example 1.4.6, we're asked to evaluate the quotient of 3/4 and 9/20. In other words, we're asked to divide these two fractions. The easiest way for me to divide fractions is dividing fractions is a lot like multiplying fractions, except you multiply by the reciprocal of the denominator. In other words, 9/20 turns into 20/9. I'll explain why that works at the end of this example, but let me continue under that assumption. Now all we're being asked is a question similar to examples 1.4.4 and 1.4.5. We're asked to multiply fractions. And the way we'll multiply fractions is by finding the prime factorizations for each of the numbers. 3 is already a prime number. The prime factorization of 4 is it's 2 times 2. And then I want to multiply that by the prime factorization of 20, which you could create a tree and see it's 2 times 2 times 5. Similarly with 9, you could create a prime factorization tree and see that it's 3 times 3. And so what you have now are the factored forms of the numerator and the denominator. We can cancel out common factors. This 3 will cancel with this 3. This 2 and this 2 will cancel. This 2 and this 2 will cancel. So when all the dust settles, all we're left with is a 5 in the numerator and a 3 in the denominator. In other words, 3/4 divided by 9/20 is 5/3. I want to now illustrate why this trick works, why 3/4 divided by 9/20 is the same as 3/4 times 20/9. And the trick here is that really I have one big fraction here. I can think about it as one big fraction where the numerator is itself a fraction and the denominator is itself a fraction. But anytime I have a fraction, now I'm talking about the big fraction here, I can multiply the numerator and the denominator of that fraction by any number I want as long as it's the same number and I won't change the value. So I'm going to get kind of clever and I'm going to choose to multiply the numerator and the denominator of my big fraction by 20 divided by 9. Note I multiplied this and this by the same number, so I haven't changed any values. What I have done is made it possible to cancel out this 20 and this 20 and this 9 and this 9. So all I'm left with is what's on the top. I'm left with 3/4 times 20/9. If you didn't feel comfortable canceling out these two 20s, you could find the prime factorization, 2 times 2 times 5, 2 times 2 times 5, and then cancel out each of the different pieces. But that seems like extra work because we could already tell that they're all going to cancel because we have a 20 and a 20. So I jump straight to this cancelization and get over here. Everything below this line is illustrating why this trick works. Going forward, I'm just going to go ahead and remember that dividing fractions is a lot like multiplying fractions, but I multiply by the reciprocal of the denominator, and I won't have to do anything below the line. I can be able to show that my final answer here is 5/3.